let's now see what classes in Java can do. So terminology, classes in Java have fields, attributes or methods, and members, other classes, or as we will see, interfaces. Java has its own syntax for static and dynamic links. For static links, it has a syntax super, which gives a static link to the class one level up, the superclass, and as we saw, it should be rarely used. And it has the keyword this, which means exactly the same as self. Java allows single inheritance of classes. This means that a class can inherit from exactly one other class. So here's an example of inheritance. We have a class point, which defines points in 2 dimensions with x and y coordinates, and a method clear to bring back to the point to the origin. Then we have a class pixel that extends point, and here in red is the syntax for inheritance. It adds a color to the point, and it redefines the method clear by calling super to call the original definition, and also then it sets color locally. So that's an example of inheritance. In Java, there is a single class called object, which is the root of the hierarchy, which means all classes inherit from object directly or indirectly. So here, for example, I define object oref. I can say assign it to a pixel or to a string or to another string. So oref can refer to any object. So this gains some of the flexibility of dynamic typing. Notice that even though string objects are immutable, oref is not. We can define oref and assign it several times. So in Java, we have the concept of an abstract class. This is a class that does not implement all the methods. So it has the headers of all the methods with the names and the arguments and types, but not the bodies, not the code. So one cannot instantiate an abstract class. We have, in contrast to that, a concrete class, which is the usual class that does implement all its methods. It may inherit from an abstract class, and of course it can be instantiated. With abstract classes, we can write generic programs. We can have a program with a missing method, and then we add the code of the method, and using different cases of inheritance, we can have different methods added. So here's an example of that. We have the abstract class benchmark. We have the method benchmark in there, whose header is defined, but whose body is not defined. So it's an abstract method. Then we have another method whose body is defined. The method repeat takes a count, an integer argument. It executes benchmark count number of times and measures how much time it takes. So we can do the same thing in Oz using functions, using higher order programming with functions. We have here the function repeat. Repeat corresponds to the method repeat, and the argument benchmark is a one argument procedure, corresponds to the method benchmark, and it does the same. It executes in a loop and it measures the time. So with abstract classes, we achieve the same effect as passing a procedure as argument. So we have used inheritance to simulate part of higher order programming. And as a final point, I would like to talk about final classes. So a final class is a class that cannot be extended with inheritance. So it's not extensible. A final method in a class is a method that cannot be redefined with inheritance. So one can be more fine-grained than just closing the whole class. So by default, though, classes are extensible. It's only when they're annotated final that they're not extensible. In fact, it is good practice to define all classes as final classes except those that you wish to be extensible. So, as a final question, is it a good idea to define an abstract class as final?